All right, now that we've learned a little bit about functions, regular functions, piecewise functions, we're going to talk a little bit about the domain and range of functions, just in generic math terms, and then eventually in context of word problems when we start modeling functions on our own. So when you're doing domain and range, it's basically trying to figure out which numbers are either going to be the input or the output of your function. Now, we will do this a lot of times in what we call interval notation. Interval notation is a way to express a lot of numbers very quickly and very concisely. So interval notation generally is when you have parentheses or brackets, parentheses meaning not included, brackets meaning included, and you're always just doing the smallest number in a set, comma, the largest number in the set, and then either another bracket or a parenthesis, one or the other, okay? So interval notation is going to have two numbers. All right, so if I'm looking at all real numbers, so every single number in existence, that's every number from negative infinity to positive infinity. And since the parentheses mean not include, we'll go ahead and put parentheses around this because you really can't include infinity because it's not really a number. So if it's a real number you can use bracket, but otherwise we will simply use a parenthesis. So B says I want all real numbers less than or equal to -2. So -2, -1, 0, or less than -2, -2, -3, -4, -5. So it goes all the way down to negative infinity, less than or equal to -2. So that would be our biggest is -2, and I would include it because it says equal to. If it just said less than -2, then we just put parentheses. C says all real numbers between 7 and 8 or larger or equal to 9. So all real numbers between 7 and 8, now it doesn't say including 7 and 8, just says between those two. So all real numbers between 7 and 8 will be 7, 8 with parentheses. So that's all the numbers between 7 and 8, 7.1, 7.2, 7.8. All those ones are in that region. Or, so it says or we generally use the U, or larger or equal to 9. So that means 9 or bigger, including 9 because it says larger to or equal to 9, so 9 to infinity. So these would be our interval notation for these sets. And this is useful when you're trying to figure out a bunch of numbers that may be the inputs or outputs to a function. So the other big thing we'll talk about with functions besides the functional value is the domain and the range. Now the domain is going to be the set of values for the independent variable. This is generally our input values. So our input values are our domain, and mathematically this is generally the x values. For the range is generally going to be the output values, or the values of the dependent variable. It's the output values for where the function is defined, and is typically the set of y values. So if I have some function, let's say I have, f of x equal x plus 2. The domain is going to be what numbers can I put in for x, and the range is going to be what numbers can I get out of the function when I plug in those differing x's. Can I get every number? Am I restricted? That's the idea behind domain and range. It's just trying to figure out where your function is defined. So some sets, the domain and range of some sets are very, very simple. So if you have a finite relation, a finite only have a fixed number of elements. The number of people in our class is finite because there's not infinitely many people. There is a countable number of people in our class. So domain of finite sets are very, very simple. So for example, if I have these 3 points, I have the point 3, 4, -1, 4, and 10, 5. The domain are just the set of inputs. The domain are just the x values. So that's just 3, -1, and 10. No interval notation or anything because it's just those 3 numbers. It's just those 3 values, so those are the numbers that be my domain values. For range, the values are going to be the y values, and the y's I see are 4 and -5. Now, obviously, there is 2 4's, but I don't need to list them twice because I'm just listing all the possible output values. These are the only values I get out. So this next one is what we call a mapping. You've probably seen this in Algebra 2 or other courses. A mapping just is another way to write a bunch of ordered pairs. So 3 pointing to 2 means this is the point 3, 2. 4 pointing to 1 means this is the point 4, 1. 5 pointing to 9 means this is the point 5, 9. 6 pointing to 12 means this is the point 6, 12. And 7 pointing to 12 means this is the point 7, 12. So only these 5 points exist in this graph. No connecting, no function, these are it. So my domain, and again, it's going to be the squiggly brackets as we're just going to list numbers, right? 3, 4, 5, 6, 7. Because it's not all the numbers between 3 and 7 because there are decimals and things like that, but all the integers between 3 and 7. And then the range is simply going to be 2, 1, 9, and 12. Because those are the finite elements. So finite elements are very, very practical in a lot of things. I could make a function. Let's just make up another one. So if I say a function, if I had your student ID, and then I had grades, then there's a finite number of grades you can get. You can get an A, a B, a C, a D, or an F. So if I take your student ID, let's say I have student 102. Maybe they got an A. Maybe I got student 103 and they got a B. 104 and they got an F. And 105 and they got an F2. And I don't know, 106 and they got a C. So you have a finite number of students, so those would be my domain. My domain would just be the set of student IDs. And then the range is the output values of the grades they obtain, and those would just be my Y values. So those would be the A, B, C, D, and F. Now the domain and range for bigger relations, infinite sets, can be a little more difficult. So if you have graphs, those often will represent infinite relationships, because if you see this first kind of parabola, there are infinitely many points on this graph. They go forever and ever and ever. There are all these points on this, and then as it goes off, there's still more points going off the graph. So when we do domain and range, we have to think about all the points. So this is where we're going to utilize our interval notation. So if you think about it, for domain, we're talking about the x. So x on the right is positive infinity, on the left is negative infinity. So this thing is going, this example, this parabola is going down in both directions, but as it goes down, it's also going left, and on this side, as it goes down, it's also going right. So the domain in this problem is actually negative infinity to infinity, which is actually a very, very common domain. It goes forever and ever and ever, because no matter what x value I pick, there's a point on the graph. X of 7, there it is. X of 4, there it is. X of 100. It's somewhere on this graph. So every x value has a point. Now range, that's not necessarily true, because it's going down, so the y values are getting smaller and smaller and smaller, so that's fine. The range goes down forever. But the highest y value is going to be up here. That highest y value is at 9. So there are no points with a y value bigger than 9. 9 is your highest y value. Now this one is similar. This one's going up and to the right. This one's going up and to the left. So same idea. Because this is going left and right forever, the domain is going to be negative infinity to infinity. But the range, we got to think about what's the lowest y value. The smallest y value appears to be at these 3 points, and that's a y of 0. Again, remember, we're talking range, we're talking y. And then this will go off to infinity, because it goes up forever, so you have y values that increase forever. Finally, you have this kind of problem. Now this one again, this one's going off the page in both directions. So the domain is going to be negative infinity to infinity. The range is going to be negative infinity, because it's going to go down forever. And the highest y value appears to be 7, and that is included. So you can pick any x value, that's why the domain goes forever, And the range value, you can get any negative y value all the way up to 7. Now, you can certainly have your domain stop too. Let's just draw an extra one just for fun. Let's say you have a problem like this. So this is the point 1, 2. So in this case, my x's don't go forever. The smallest x, the point with the smallest x is this. There is no there's no point with an x smaller than 1. So in this case, my domain would be 1 to infinity. My range also is limited because the smallest y value on this graph would be 2, and the highest y value would go off to infinity. So domain and range of infinite relations, obviously this is something we're going to practice a lot because it definitely takes a while to get accustomed to figuring out on an infinitely large graph which values do you include and which ones don't you. So that's all for domain and range. If you have questions, obviously, please do let me know.